You know, when you think about these massive, high-pressure industrial plants, it's easy to be impressed by the giant towers and complex machinery. But what if I told you the difference between everything running smoothly and a billion-dollar disaster could come down to a single component, no bigger than your fist? Today, we're diving into the hidden science of that component, the bolt, and the incredible engineering that literally keeps our world from falling apart.
All right, so just try to picture it. A sprawling oil refinery or a chemical plant. It's basically a city of steel and pipes, and it's all operating under immense pressure and extreme temperatures. With all that heavy-duty, complex hardware, what do you think is its most vulnerable point? The one single thing that's most likely to cause a major catastrophe.
It's kind of crazy to think about, right? It's often not some giant reactor or a towering distillation column. The weakest link, so often, is just a single, improperly secured bolt. It's a shocking thought, and it perfectly sets the stage for why the science of getting it just right is so incredibly critical.
Okay, so to really get why that one little bolt holds so much power, we need to look at where it lives. Let's start with the anatomy of a true unsung hero of all this industrial piping, the flange.
So what is a flange joint? Well, it's basically the meeting point where two pipes, or maybe a pipe and a big piece of equipment, are connected. The best way to think of it is like a high-tech sandwich. You've got two big steel faces, and squished right between them is a gasket. Then, bolts are run through the edges and tightened down to create a perfect seal, a seal that has to hold back some incredible forces.
And if that seal isn't perfect, oh boy, the consequences are, well, they're severe. We're talking about dangerous leaks of flammable fuels, serious environmental damage from escaping gases, and just major safety hazards. A single failure can shut down an entire facility, costing millions upon millions in lost production and repairs. The stakes really couldn't be any higher.
So how on earth do you guarantee that seal is absolutely perfect every single time? Well, it all comes down to how you tighten the bolts. And in the world of high-stakes engineering, this isn't as simple as just turning a wrench. It's really a tale of two competing forces, torque versus tension.
These two methods are just fundamentally different. Torquing, that's the twisting force we're all kind of familiar with, right? Like using a wrench to tighten the lug nuts on your car. But tensioning is a whole different ballgame. It's a pure stretching force. The best analogy for it is like tuning a guitar string. You're not twisting it, you're pulling it to a very specific load to get that perfect result. Now, here's the huge problem with torque. Get this, somewhere between 40 and 70% of the twisting energy you apply is lost. Just gone. Eaten up by friction between the nut, the bolt threads, and the flange surface. That means a massive chunk of your effort isn't actually creating a seal at all, it's just fighting resistance. And that friction is super inconsistent, which makes the final clamping force on the bolt incredibly unpredictable. So, to try and deal with that friction and get an even seal, technicians have to follow this incredibly meticulous process. I mean, it's like a complex dance. They lubricate everything, then they tighten the bolts in a specific star pattern, not all at once, but in multiple passes. First to 30% of the target load, then again to 60%, then finally to 100%, and then they do one last check. It's a whole procedure just to try and achieve some consistency. Now, compare that whole dance to the tensioning procedure, which is way more direct. Here, a hydraulic tool fits over the nut and grabs the bolt. It uses immense pressure to physically stretch the bolt, kind of like a high-tech rubber band. While that bolt is being held in its stretched state, the nut is just turned down by hand until it's snug against the flange. Then, when the pressure is released, the bolt tries to shrink back, and that locks in a super precise amount of tension. It completely sidesteps the whole problem of friction. And the difference in the final result? It is absolutely staggering. I mean, look at this. Because torquing is always fighting that unpredictable friction, its accuracy can be off by as much as 25%. That is a huge margin of error. But tensioning, because it directly stretches the bolt, achieves an accuracy of plus or minus 5%. In these critical high-pressure situations, that difference is everything. So as you can probably guess, you're not doing this with a simple wrench from the hardware store. Achieving this level of precision requires a whole suite of advanced high-tech tools, and each one is designed for a single purpose, achieving absolute total integrity. The modern toolkit for this is it's incredible. Of course, you have your heavy-duty hydraulic torque wrenches and bolt tensioners for applying the force, but then you also have ultrasonic sensors that can measure the actual stretch of a bolt down to the micron for the ultimate accuracy. Before you even start, laser scanners check the flange faces for any microscopic imperfections or warping. And to tie it all together, all of this data gets fed into management software that tags, tracks, and documents every single step for every single bolt.
But you know, all this incredible technology, it all serves a much larger idea. This isn't just about tightening bolts. It's about embracing a comprehensive zero-leak philosophy. See, a successful, totally leak-free joint depends on a whole system of best practices. It means selecting the exact right gasket for that specific job's pressure and temperature. It means making sure the load is perfectly uniform across every single bolt. It even means precisely controlling the lubrication to manage friction. And, critically, it's also about avoiding over-tightening, which can be just as dangerous as leaving a bolt too loose. Every single action is documented.
It all really boils down to this one mission statement that drives the entire industry. It's a powerful, simple equation. Zero harm plus zero leaks equals zero compromise. It's the perfect way to connect the engineering precision we've been talking about directly to the safety of people and the environment.
So here's the bottom line. Preventing a billion-dollar disaster isn't about one magic tool or technique. It's about a disciplined, data-driven system where the gasket, the steel, the lubricant, the load on every single bolt, all of it is measured, controlled, and documented. In this high-stakes world, every single tiny detail matters.
It really makes you wonder, doesn't it? The next time you see one of those massive industrial structures, remember the hidden science of that flange joint holding it all together. And ask yourself, what other invisible, high-stakes processes are out there, working perfectly right now, just to keep our world running?